Hello, everybody. Today we're talking about transformation of energy. Okay, so transformation of energy is kind of based on this concept of the law of conservation of energy. It's the first law of thermodynamics. And basically, what it says is that energy cannot be created nor destroyed, only converted from one form to another. Okay, so let's say we did this one right here, this FET skater ramp, and there's no friction involved. Friction adds a little bit of a complicated element, but we're not going to talk about that right now. We're just going to talk about this skater right here on the ramp. Okay, so this skater right here, if we were to let it go, it starts as potential energy and it goes to kinetic and then back to potential, and then kinetic, and then potential, and then kinetic. And by the way, potential and gravitational are the same thing in this situation. But the total energy does not change. Okay, the total energy does not change. If I were to do that FET energy skate park right here, you'd see that I would do this and it basically stays the exact same the entire time. All right, I'll even show you. So here it is. I'm going to put on my bar graph and watch. The total energy is not changing. It is only transforming from one type to another. Okay, cool. So we're going to be talking about that. We're going to be talking about systems. And if you're asking me and you're saying, well, the energy within the system doesn't change, but you had to give it energy, and you said energy can't be created or destroyed, right? So how did the skater give its initial energy? Well, and I guess you can say I put it up there, me, my finger, okay? But in real life, there's probably like a you can either pump up or you can kind of climb a ladder to get up here. And let's pretend they climbed a ladder. Let's pretend for a second that this skater, to get up to here, they climbed a ladder. So they started down here and then they climbed up and they got energy. Well, where did that energy come from? Well, it's kind of a long story, but basically the energy came from doing work from the muscles. So the skater was climbing up, using like her muscles to get up, climbing, arm muscles, back muscles, leg muscles to get all the way to the top. Okay, well, where does that energy come from? Well, that energy comes from the food we eat. Okay, so where does that come from? Well, the food we eat, even if it's animals, eventually come from plants. Okay, or where does it get its power? Well, it gets it from the sun. Okay, so this right here describes energy transformations. Okay, so the nuclear energy of the sun is transferred to solar energy, which is transferred to chemical energy, which is sugars stored in the apples. You'll learn more about that in chemistry, which we eat. We then break down those sugars and we can use those to activate muscles, and our muscles climb us up to the top, and that gives us potential energy. So these are transformations of energy going from one to another. But there's also this concept of a system, where basically now we have this system, and this system is only from the skater and the ramp. Okay, we had put energy into the system from the outside universe. Okay, so that is called a transfer. So there's two different words here: transformation and transfers. Transform is when one type of energy turns into another. This right here is transforming. It's going from potential to kinetic, potential to kinetic. Okay. Transfer is when one object gives its energy to another. Okay. So up here, you remember from the ball and ramp lab, is we took energy and we used our muscles to put the ball on top. So we're taking energy from our body and putting it into the system, which was the ball and the ramp. In the example we just used, the transfer of energy went from the sun to the plant to the apple to the skater. Okay, so transfers from one object to another, transform is from one type to another. And a system is basically a portion of the universe that we isolate just for the terms of study. So in this case, the system is this skater on the ramp. Okay, cool. The example that we used right here was basically in this case, the chemical energy of whatever this kid ate was transformed into mechanical energy, which is kind of like movement energy, and lifted the ball up, and it was transferred to the ball. Okay, cool. So what I'm going to have you do in the homework today is bar graphs. And bar graphs represent the different amount of energy. The total energy doesn't change. So basically right here, this is always going to be kind of like this total right here. These things right here can change, but the total doesn't change. And all of the bars have to equal the energy, the total energy. Okay. Um, so it's not going to change there. So we also use some abbreviations. So ET is the total energy, EG is the gravitational potential energy, EK is the kinetic energy of movement, E, oh, there's two of those, my fault. ETH is thermal energy. Thermal energy is energy that's heat that's produced by friction. Okay, so whenever we're talking about friction, it produces thermal energy. Elastic energy, that's when we're talking about springs and rubber bands and stuff like that. And then there's also chemical energy right here, but we're not going to be using it that much, but it would be the apple that they ate. Okay, so in this, what you're going to be doing is you are going to be analyzing these different situations and you're doing calculations, and you are also going to be doing graphs. I could already see an error right here, which I will fix. So let's say the total energy for this skater was at 100 and the gravitational is at 60. Well, that means that the kinetic is equal to the 100 minus the 60. So this right here would be 40 joules. All the types of energy have to equal the total type. So then I have 60 and 40. So what I do is I double click here and I would draw the bars. And to draw the bars, I click on this and the shape, and I say, okay, it's like 60, and it's like, the kinetic is like 40. So this one should be bigger than this one. And ideally, although it would be kind of hard, um, these two should add up to equal that, but that's not super necessary. So it would look like that. Cool, cool. There's a few ones like that, and you kind of just have to analyze the situation. On this one, the ball starts up here. It's all gravitational potential energy. It rolls down, but then right after it enters the ramp, let's say it's on grass, it gets some friction, and then it stops. Okay, so that one's kind of unique with that one. This one, there's a rock that's put onto a spring, and it shoots up in the air. When it gets to position C, it's at its highest it's going to be. So it's all gravitational energy there. And right here, it's mostly elastic energy because it's in a spring, but also it's a little bit off the ground, so it's a little bit of potential energy as well. Cool, cool. I will talk to you later. Take it easy. Peace.